ain't afraid of no hype. Oh, who you gonna call? I ain't afraid of no hype. Hypebusters.
You notice from that little intro there, I have gotten the tiniest bit into actual video editing as opposed to trying to run through these videos in one cut. And then so I'll leave the actual full length of the intro video that I've created for this series, or like the kind of like the theme song for this series, at the very end of this video, so that you can listen to it if you'd like. And then I'll leave the full theme song on my second channel, and I'll leave a link to that in the description for this video. So diving directly into this, today we are going to talk about a research paper, and this research paper is called Large Language Models Orchestrating Structured Reasoning Achieve Kaggle Grandmaster Level. And so off the top, I wouldn't have any sort of problems with this research paper, except for the way that it's presented, their methodology within it, and the fact that how they're trying to represent these results, right? And then off the top, I'll say, like, the reason why I'm able to recognize these patterns is that I've engaged in them myself. I've worked for companies in which I've utilized these tactics, and I've utilized these tactics myself. So, like, I'm just flat out, like, I know what to look for, right? So, let's dive into this paper. So, starting off the top, I'll just highlight a few things here, and then we're going to go into like the actual bulk of this criticism itself. But I just want to highlight, first of all, why did this come to my attention, right? So the very first thing is that there's a big Reddit post about this in this research paper, lots of upvotes, right, etc. Like lots of publicity. At that point, you can tell that they're paying for publicity at this point. They also have this Hugging Face. It's the #2 paper of the day. They researched that they published. They've put money into marketing for this, basically. It's the bottom line, right? I can tell you up front that there's no way that this type of paper gets this sort of publicity and this sort of engagement on a paper, especially like this, without money behind it, right? If I released this type of paper, and there would be nothing behind it, right? And then as you can see, it's put up by Hawaii, right? That's kind of the very first thing. And then, so just noting that up front, I mean, flat out, it's Hawaii plus like nothing is good as far as an actual research institution behind this, right? Like, so up front, like the archive research submission process is that, so like if you're a company like me, then generally speaking, you have someone on the academic side that submits these papers for you, right? And then so like if you're Microsoft, Google, etc., usually speaking, you have someone that's submitting these papers from like Stanford University, etc., like big universities, right? And that's kind of how this works, and how you go through it. And then it looks to me just flat out like Hawaii, the company, the cell phone company, wants to get in on this like this game, but they just went out and got, like, I mean, I could pay for this. I could pay for a University of Dart's TAP research institution person, right? Like anyone that is involved with an academic institution around the world can submit a paper. So any company like myself could go onto Fiverr and get someone to publish a paper like this on archive. Just noting that flat out. Secondarily, the second thing to note with this paper that caught my eye just immediately is the fact that it's an 88-page research paper, and then only 30 pages of it are the actual paper itself. The third thing that catches my eye about this paper is it's very dense to read through, and I think that's on purpose, right? Like, you look through it, it's a lot of mathematical equations, a lot of math, and a lot of dense math, right? And then so all of these things, I think, are very purposeful to go in this, which is why I'm making this video. So now let's go ahead and deconstruct and essentially rip apart this research paper. So again, this research paper is very dense with what it's presenting, right? But let's break down what it is actually presenting. So the researchers behind Agent K report submitting to a total of 65 Kaggle competitions, and the breakdown of medals achieved was as follows: 6 gold medals, 3 silver medals, and 7 bronze medals, which equates to about 25% success rate as far as submissions here, right? So out of 65 submissions, 25% of those submissions received a bronze medal. So let's first of all talk about these competitions. These 65 Kaggle competitions, as noted in the research paper itself, as you read it, are cherry picked, right? They are like community playground. You can the least amount of submissions possible that you would submit to kind of game these results. Like if you were to create a new mechanism, a new award for being able to have an AI model achieve Grandmaster in Kaggle submissions, there's nothing stopping you from submitting to every category or the smallest amount of categories with the lowest amount of submissions, right? Like they're literally making up their own award mechanism in this instance. And then so that's like, I mean, flat out, like I've done this for companies in the past, right? Like, I'll give you an example. Like if you in California, if you've ever gone to like AM PM gas stations and then you've seen top tier served here, reason being behind that is all gasoline within California is top tier. And then so when you can do that, when you can pick your own, like, hey, we can out of everything, we're going to pick Kaggle Grandmaster. All of a sudden, you can everyone achieves that award. Like everyone that is your model achieves that award. But then secondarily, that's just the competition framework. Let's break down how these medals are presented, right? Because it's not like, these are big achievements. Gold, top 10%, sure, right? But silver, top 30%, and then bronze, top 70%. When I was in college, I competed in speech and debate activities. And it's very popular that you would break or have like 50% of the population up to like 40% of the entered crowd get like bronze medals. And then that was kind of absurd. This is 70%. Literally 70% of submissions get a bronze medal in this instance, and then they are counting that towards their rewards. So not only are they, one, creating their own, this is our own category of recognition for what an AI model and agentic AI model should be, which should raise your first red flag. Secondarily, we're gaming the competitions that we actually enter within that. And then third, we're misrepresenting how these rewards actually work. And it's 70% of all submissions actually get a bronze medal. On top of that, our total award rate out of our 65 submissions is 25%. And I'm running that up, not down, just giving them the benefit of the doubt, right? And then more importantly, so let's dive into number two, breaking down this Kaggle model. So that's the performance of the model, but breaking down the actual inner workings of the model flat out. Everything that is represented within this model is off the part open source products. There's nothing that is within this Agent K that these people have actually built. They utilize three key technologies within this: AutoKeras, RAMP, and Hebo. And all three of these are off-the-shelf open source technologies. If you read through the research paper, very specifically, a lot of that math that they represent and a lot of their methodology that they represent is this Bayesian optimization, which is all 100%, 1,000,000% related to this Hebo optimizer that they're pulling off the shelf. And then it's literally just off the shelf that they're pulling this from. And then so they're not doing anything within this, right? They're just putting pieces together. It's possible that no one has ever put together AutoKeras, RAMP, and Hebo together before in the exact combination that they've put them in. So they might have some uniqueness within that, but that would be literally the only thing that is unique within what they're actually doing within this. I can't state that enough. So their math isn't new and what they're doing isn't new, right? But they're presenting it in a very complex and complicated way. So breaking this down further, let's simplify what Agent K actually does, right? The actual process of Agent K. So the first is that this agent takes a Kaggle competition URL, and then it uses the Kaggle API to download the data sets and the task descriptions. Data is then pre-processed and organized into structured formats, and the system generates Python scripts, blah, blah, blah. So First thing to note within this is that any submission that it's submitting to has to have up front the data to download, the data sets and the task descriptions. So all competitions that it's submitting into in this instance are against bots flat out, because it has to be because of the technical rules of the data set competition. And then so within that, it's still getting, for a bronze medal, it's still getting beat by 70% of the bot competition. So it's against bots and it's getting beat by 70% of bots in that category. And then that's what they're advertising to you in this. Is that revolutionary in any way, shape, or form? Should that be advertised to you? I mean, I'll leave that up to you. 2. Solution generation phase. Based on the type of task, the system selects the appropriate tools. So for tabular data, it uses the, again, off-the-shelf auto ML routines. For computer and vision and NLP tasks, it leverages PyTorch and off-the-shelf fine-tuned models from Torch Vision and from Hugging Face. And then the agent applies Bayesian optimization, which the paper utilizes and goes off of a lot on, except for the authors of this didn't create this. They're just using Hebo to further fine-tune the models for maximum performance. After that, it performs a submission and a feedback loop. So after generating predictions, the agent formats the results according to the competition's submission guidelines and then submits them via the Kaggle API. And that's all that's going on here, right? It's not like it's doing like first order predicate calculus. It's not like it's a first order cat or anything like that. It's just very straightforward, going through and doing a very, very simple process within this. Let's dive deeper. So what does, like, all of that complex math, what are they doing within that math, right? The bottom line is that this, all of this math that they present, right? Like all of this, like this big scary math, this is what's called PPO optimizer, except for they're simplifying it. And then so a PPO optimizer is utilized very specifically for reinforcement learning, right? And then so I have one of these maybe. If I didn't just close the wrong one, but maybe I did. Well, I can use an example of RLHF, right? So there's reinforcement learning and RLHF. Reinforcement learning is essentially, it utilizes a PPO optimizer, whereas RLHF uses a Q learning optimizer like QStar or DQN network. And then so like that's known within this. If you're doing RL, it's always PPO, right? And then so within their methodology that they're laying out here, same thing. It's always PPO. Again, they're not doing anything like, they're not putting in first order predicate calculus. They're not doing anything like that, right? They're just using a simplified PPO optimizer and then presenting the math to you in a complex way, like they're doing something new and unique, when they're actually doing something that's been done way before in a more simplistic way. And then they talk all about this role of memory and how it works and like this whole breakdown of this revolutionary memory concept, right? That's the whole entire concept of the PPO. If there's anything at all that is like revolutionary within the mathematics of this, it's that off-the-shelf Hebo fine-tuner that they're using. And that's pretty cool because it doesn't utilize backpropagation, which they note and utilize within their paper, and they highlight that. But again, that's because of off-the-shelf Hebo, not because of literally anything at all that they're doing. So that's an award to Hebo in this instance. So overall, the final takeaway is that this paper isn't doing anything, right? It's not doing anything at all that is unique. It's a reinforcement learning algorithm that utilizes a simplified PPO algorithm as opposed to anything else that you would find off the shelf. And it's utilizing 100% all off the shelf parts. There is not a single thing that is unique to the research overall that this research paper introduces. This research paper flat out should not exist. exists. The only reason why it exists is because this company, Hawaii, wanted to put out a research paper to fool anyone that is foolish enough to look at this and say, hey, there's a bunch of math. I don't want to look at this 88-page research paper. Congratulations, Hawaii. And it's all just a bunch of garbage, and it's literally expected that you're not going to research or read into the 88-page research paper or understand it. If you do, it's actually just a bunch of garbage and wasted digital space in this instance. If you like this type of content, please like and subscribe. And then here comes the outro music. Thank you very much.
If they're selling dreams and it's understood that it won't quite work, but they said it would, who you gonna call? Hypebusters. If the jokes don't land, the claims don't sink when the pitch sounds slick, but it starts to stick, who you gonna call? Hypebusters. I ain't afraid of no hype. 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 When the demo's cool, but the code's a mess, and the numbers don't jive with what they profess, who you gonna call? Hypebusters. If they're saying AI can do it all, but behind the curtain it's just smoke and gall, who you gonna call? Hypebusters. Fake data in the skies, tricks and empty lies. When the jargon's thick, but it's all just a flick. You need some hype to bust. Yeah, we're the